Hello, I'm John Chivacco, the co-chair of the NY-GEO 2023 conference and a board member of the New York Geothermal Energy Organization. I'd like to welcome you to this recording of a live presentation from the conference, a two-day event which was held in Albany, New York on April 26th and 27th of 2023. This year's educational sessions and keynotes represent the latest in ground source heat pump system design, product innovations, and installation practices, along with important policy, regulatory, financing, and incentive updates. This presentation is one of over 40 sessions from the two-day event, all of which were recorded and available at NY-GEO's website, www.ny-geo.org, along with session descriptions and a link to download the slides from each of the sessions presented. NY-GEO is proud to make this content available to our members and other industry stakeholders, and if you are a member, thanks so much for your support and participation. If you find this content valuable and for some odd reason you are not yet a member, consider joining NY-GEO at the appropriate membership level with details available at our website. The live recording from the NY-GEO 2023 conference will start in just a moment. Thanks so much for listening.
I am Kevin Moravec, New York GEO board member, Barney Moravec Incorporated, Van He Heating, and today we're going to talk about how geology matters, thermal conductivity testing, and drill logs. And I'm going to go through each person here, let them introduce themselves a little bit, and then I'm going to pose a question, picking on engineers a little bit, picking on drillers a little bit, picking on the TC guys a little bit. Something that's near and dear to all of our hearts. When you see a bid that comes to you and the drill information that they give you is 0 to 60, 0 to 70 till 70 to 120 shale, 120 to 500 shale, doesn't make any water, doesn't make any gas, doesn't show any salt, and then you have to bid that job. And so we'll get into that, but first, I am going to start with Jeff at the end. Introduce yourself, Jeff.
Yeah, good afternoon. Jeff Urlaub, MEP Geothermal, Salas O'Brien. I'm a mechanical engineer, and I've been involved in the geo business since 1998.
Richard Moravec. I'm his uncle. And family water well drilling business, geothermal business. We've been in business since 1934. Geologist and master groundwater contractor with NGWA.
Welcome. I'm Garen Ewbank with the GreyEdge group, with Ewbank Geotesting, and with Next Temp Solutions. You'll hear more about some of those maybe through the rest of the show. But anyway, I've been in this industry for a very long time. And this is probably the first time you've had a past president and a current president of the board setting up on a panel. Okay, here you go.
I'm Kortney Lull. I'm with Midwest Geothermal. I am also chairperson for the IGSPA, International Ground Source Heat Pump Association. But with Midwest Geothermal, we're a drilling contractor. We install closed-loop systems across the country.
Okay, so how many people in this room have been asked to do a test bore? Raise your hands. Okay. How many people in this room have been asked to perform a thermal conductivity test on test bore? Okay. How many people in this room have been asked to bid a job that you did the test bore for? How many in this room have been asked to bid a job for a project where you did not do the test bore? Which one do you prefer? That's a big piece of what I want to talk about. So we've all seen these scenarios over the years. We know that the engineers and the building designers and the contractors all need to know how that ground loop is going to perform. Garen, you've been doing TC testing for how long? Microphone.
So when I got into the business, everything was residential. And I knew that designers weren't going to do commercial systems without knowing the local earth property. So I worked with Oklahoma State University, and I performed the first test in December of 1994 in Davis, California. So that's when.
Okay. Jeff, how long have you been designing geothermal systems?
Since 1998.
And how valuable is that TC information for design?
I would say the TC test results have less risk than the actual drilling, understanding the formation. Because we all know when you look at, drill logs, well logs in a site, you got a really good handle on what the TC of that formation is going to be. I feel that the drilling of that test hole and gathering the proper information and giving the driller the proper time to actually maybe adjust with a different method doing the test hole, because we have to understand the production and everything else about the formation, has the largest risk of going over budget on a project.
So with that in mind, we have kind of the originator of TC testing. We have a designer that understands the importance of the drilling piece. Have you ever hired a third party, or have you yourself gone and sat a test bore to verify the information that is being given to the drilling community?
Yes, part of our proposal when we do a test is we have a person that actually went through the ICSPA certification, and he's there full time, and he actually does his own logging. And when the driller takes a break and whatever, let's say he has some maintenance he has to do in the rig, well, we note that. So, because we really want to understand the production rate, right? And the type of, is it air, mud, what type of bit, type of PDC bit, blah, blah, blah. So we want to gather all that information, which is very important. But also, like I said, if we start out with air, we hit water, now we're going to have to go to maybe a mud road or PDC bit or something. We have to understand that and give the driller time. We have to, hopefully they put enough money in their test that they can actually then play with different drilling methods if we need to. Because you never know, you might encounter something that we didn't expect.
Okay. Rich, as a geologist and being in the business as long as you have, drilling, I just happen to know more about what you do than pretty much anybody else up here. How much does geology change over half a mile, over a mile, over 100 feet from site to site?
Everybody in here that drills knows that things change so fast, so rapidly. From, it was a thing that I always found when I was in the environmental end of things and traveling around, and how fast geology changes, and trying to relay that to our engineers back in the office, and they couldn't quite understand why I did that, because it didn't fit into the pattern that they were used to. So when you can stand somewhere in the Finger Lakes and be standing on bedrock and look across at bedrock across the other side of the road and know that a well was drilled in between there in a distance of a couple hundred feet and ran 140 feet of casing, things change quick. You can be out in Lima, New York, and standing in a flat, dead field and know that you can run 305 feet of casing and it flows, and go a half mile down the road and hit rock at 20. And so this happens everywhere. And then it's the type of geology that it is, because we have a certain dip. The rock tilts from north to south. And you get various types of geology. And a lot of that is never recorded, and it's never understood. And what formations you see on one part of a site and go 300 feet away, it can be night and day. And we've all seen that. Unfortunately, that doesn't get documented. Or you get one test well on a 150 hole field, and it just doesn't apply. So it happens. It's greatly varied.
Kortney, how many different states have you operated in and drilled geothermal holes in?
10, 12?
What's your favorite state?
I don't know if there's a favorite. Well, Michigan is very unique, right? So much like New York, the glaciers came through, and now it's a bunch of junk all the way down. We're unconsolidated almost the entire distance in any bore we drill, but then we run into certain areas of the state where we're also standing on bedrock, like it's only a couple feet down. So I don't know that there's a favorite. I mean, there's certain areas of the country we enjoy going to more only because of what's there. Like the food's really good certain places, but as far as drilling goes, it really is just dependent. I mean, when we've drilled in New Jersey, it's very consistent rock, almost at surface. But it's slow, and you get a ton of water back at yourselves. So certain drilling techniques aren't always a great option. So it really is just, it's a big mixed bag depending on where we are.
How do you choose which drilling method to use on different sites?
So it starts with the TC test, right? So we want to start making that determination when we see a drill log. Well, the biggest challenge comes in is when you leave it up to the drillers and they write that it's gray rock. I don't know what that means because lots of rocks are gray. So when we look at engineering firms who spec it, and MEP does a great job of requiring someone else on site to witness, or we have a geologist. But we have to find a good common language between a driller and a geologist is I don't know what a Jurassic period rock is. I need to know whether it's limestone or sandstone or shale or whatever else may be the case, or the difference between a boulder and gravel. That's a very different drilling technique and the things that we need to use in the borehole. But it is just dependent on site conditions as well. So using the example in New Jersey is a great opportunity, right? So drilling air there, you're getting hundreds of gallons a minute back at yourself. It's red. So that's not a great thing to dispose of because everyone will see it. And when you're in a tight neighborhood, everyone's very concerned. So we ended up having to switch to mud rotary, which is slower, but we don't have the water discharge, right? That's also where we run into trouble with TC testings is understand what you're asking for when you're designing that TC test or request. We've seen TC tests that came back, everything looks competent. Then we found out the fact that they sonic drilled, didn't see the cavern because they sonic drilled. So we're trying to drill with traditional drilling techniques and we can't because we've now encountered a 20, 30-foot void. And so now we have to go back to the engineer and say, so unless you find another sonic driller or the one who drilled your test bore can come back, this can't be drilled this way. So we're really, these TC tests are so much more important than just getting the conductivity data back, which is important, but it's really ground conditions. It's understanding that whole depth and really understanding what you're asking for. When you're using those specialty drilling techniques, you really have to communicate that as well, because otherwise the bids you're going to get are going to be kind of worthless if we're mostly looking at it from traditional drilling techniques.
I mean, it's one of the biggest complaints I think that we've all heard, biggest barriers that you hear from developers and policy and utilities is the drilling is too expensive. It's too unknown, right? It changes. And so what do we do to fix that? Garen, how many TC drill logs have you seen over the course of your career? Rough estimate.
Thousands, seriously, okay? So when you get into this, guys, I want to kind of hit two things right off the get-go. One is we need to train our architects and untrained engineers to give you a location where you're going to go. First of all, X marks a spot, all right? So that's latitude, longitude, something like that. And after we get that, there's some very good ways to log the process. And if you don't have a copy of it, Sound Geothermal has one of the better examples of that, and we teach that in this Certified GeoExchange Designer and Inspector and a couple of the other courses. So it's there. So anyway, now what was your question?
Does anybody remember my question? So how many drill logs? Yeah, you saw
Well,
you've seen thousands.
Yeah, I thought I did that, but yeah, okay.
So what, out of those thousands, within a given area, say, what type of variances are you seeing in the actual conductivity results?
Generally, I'm seeing anything from about a I'm using the Poundle system, guys, okay? About a 0.6 up to about a 3. Predominantly, it runs in the range of about a 1.6 is going to be a normal, what we see out there, so if that helps.
I think most in New York, we see anywhere from 1.1, 1.4, 1.6, so that sounds about right. As we look at how we want to grow this business, how we want to expand the adoption of this technology, is there, or have you, Kortney, ever shared the actual drill methodology on a log for a test bore for competitive bid, not in a design bid situation?
Yep. I prefer to. And most of the time, so when you're using testing companies, they're going to ask you the method that you drilled with, because the method you drilled with is also going to dictate how long the bore has to just hang out and reacclimate into what normal formation situation would be. But all the time, I prefer it when we see drill logs, not to keep shooting the horn for Salas O'Brien down here at the end, but they do a great job of recording not just drilling type, but drilling times, so that we know roughly what they encountered and how long it took them to drill a hole. I mean, that's not always the best guideline, right? Because you're drilling a test hole. You have no idea what you're going through. So that may be slower or faster than what the actual project will be. But we need more information. We need more information on those TC tests so that they really are valuable. Because as drillers, what are we going to try and do? Mitigate risk. So if we don't see that information on a drill log, if I don't see that they mud rotary drilled in an area that maybe we would have said, oh, it should be air drilled, well, I'm immediately going to assume risk, right? I'm going to assume that I don't have all the information, and all that does is drive the cost up. So giving more information, having someone out there, I mean, make these TC tests worth it, and then you'll have a better price down the road.
Has anybody, I mean, I've only worked New York State. Obviously, we've got all kinds of experience here. So has anybody seen in the bid process where that information is required to be shared from the driller? Buddy?
It's required in the specifications when we get the TC test request. So yes.
Okay. Trying to think of the next question I had, and I lost it. I will take a minute if we want. Yeah, go ahead.
I can stand on your one question. The answer. So the whole goal is to mitigate risk for the owner, but also to mitigate the risk for the drilling company, because we do not want to see a drilling company lose money. So when you talked about unconsolidated material on top, it could vary from 0, let's say, to 100 feet over a whole site. So if we see a lot of variation, because we're going to have to set some casing, and we want to make sure that the driller puts in enough casing per hole. So we've done geophysical testing where we'll map 0 to bedrock and do a 3D drawing to show exactly where the bedrock layer is through that whole site. So then the driller knows exactly how many feet of casing is needed per hole, because it could vary from 25 feet to 100 feet on this typical site. So we are trying to help the driller mitigate the risk of how much casing is going to be in his bid, even though you can do a line item, per foot of casing. But also this helps the overruns, for the client. So we just got to help and do a lot more logging and, beef up the specifications with information so the drillers know exactly what they're going to encounter.
I'll just add to that a little bit. The other thing that it does help is by having really good data that is supplied on the bids, you're going to get more people to bid on it because they know, and that's what you want. If you want to help keep the cost down, you want to prevent overruns, you have that data supplied and you make sure it's documented and documented very well, timed out, everything about it. And then you will get more bidders because they'll have a lot more confidence in putting, you know, their butt's on the line and their company's on the line and not get hung up so long. They'll know exactly a time frame. They know what they can do.
How many people, does this work as well as the other one? I can't hear myself talk half the time. How many people in the room have accepted bids from drilling contractors, you know, 2, 3, 4 bids on a project that you're looking at? Give me an arm. Somebody's done this. Okay. So what kind of variance do you typically see between the magic high bid and low bid? How big is that spread that we've seen? Just percentage.
About $5 a foot.
It was $5 a foot so that the recording device has it? That can be a big number. Hold on. Double fisting.
There we go.
It's not till 5.
I'd like to echo what the panel has stated. When we spec a TC test after we pre-designed the field, we require that that driller furnish the drill log. Now, it may not be to the Unified Soil Classification Standard, but being an ex-petroleum geologist myself, I'll make sure that, you know, we have an idea of that geology. The other thing is, for like the Rocky Mountain area where I'm at, most all the drillers know each other, so they can read each other's drill logs. They know what they speak of. But the other thing is, leading up to this, I think it's important to note, if you have 5 bids and you can spit on 4 of them and hit the numbers, and one guy's like 20% lower, he's probably in the situation he either doesn't know what he's getting involved with, or he's a change order artist. And the latter is what I usually run into. So we finally, a lot of architects and general contractors, I've said, let me review the proposals. And we had one recently from a guy that came 5 states away, and he was cheaper. Well, he didn't know what he was getting into. Well, they went in and selected him. Well, they call the Rocky Mountains for a reason. And this just happened to be an alluvial rock pile. He was sent packing in about 1 week. He couldn't deal with it. So you want to use experienced people that know what your conditions are. But if you see a big disparity in bids, don't assume that the low bid can do your job. Find out why.
Thank you. Does anybody want to be my
Get my exercise.
my question guy?
You want me to be
Want to volunteer? Terry, I will accept your offer. I appreciate it.
I need the exercise.
There you go. You can probably breathe better here instead of that mile-high Rocky Mountain stuff, right?
Too much air here.
A lot of hot air in this room as we get by the end of the day. You wait.
Air enough there.
Yeah, any questions? Let's open it up a little bit.
I had a project bid in Colorado. I had 4 bidders. As a residential 4-ton heat pump, I had 4 different bids. They went from 700 total feet to 1,000 total feet between 2 and 4 boreholes. So it's quite a significant range.
Yeah, you want to put everything on the same page so you can make a good judgment call.
So I guess I'll go down the line with our panelists here while everybody in the room kind of collects their thoughts and comes up with the next really good question, because we like questions. Jeff, how do we make this process better and more transparent to everybody in the community, the drilling community, the bidding community?
Well, I guess, first of all, we have to give the person that's doing the test hole more time. So we have to make sure that they have enough money in their proposal to spend a little more time with drilling. Second thing is the logging, and then have a second party or third party person there doing the logging and verify with the drill log that the drilling company put together compared to your log. because we found out they do, they don't match up a lot of times. So you got to remember too, the guy that's doing the test hole, you know, they want to keep a little to themselves, so they have a little advantage when the job comes out to bid. So we got to try to gather as much information as we can to provide that in the specifications to try to give the other bidders that didn't drill the test hole enough information to put an accurate bid together.
I'm gonna no, I'm good. So I'm going to supplement that thought is that independent, that third party logger who's going to sit that hole shouldn't be just somebody from the engineering, the architectural firm who knows nothing about logging a hole, knows nothing about geology, knows nothing about the area. Drillers know a lot of things. They know a lot about how to get a hole down and when their air's on and when there's not, and when they're running water or they're running soap or they're running something to get the hole down. And the average person in an office isn't necessarily going to know that. So if you're going to have a third party, you're going to have somebody aware. And you're going to have somebody that's going to be there to watch what goes on. Because there's a lot of things that we all can do that maybe not everybody knows about.
Well, firstly, you probably want to review some of the history of the driller that you're going to employ. Has he done this before? Does he know where he's headed? And are you going to have to log it independently? And we're finding that the independent logging works better. And one of the firms I'm with, we actually send out a geologist to set and record all that stuff. So when you get that log, you know it's accurate. And that's really important. The second is on the testing itself, the data is starting to change, all right? The whole industry is going to a, quicker, faster, cheaper mentality. And so Rick Kleminski, he's back here in the back. Raise your hand, Rick. He and I have been working on some procedures to do exactly that. And with that, we're going to see some improvement in the industry. And hopefully we get more geologists involved in what we're doing at the onset. If they could be there on that first in situ test borehole, it's really important. In Oklahoma, what we've done is when you do an in situ test, that's exploratory drilling, all right? When you do the boreholes after that, all right, that's developmental drilling. The caveat is the developmental drilling has to stay within the parameters of the in situ test drilling. You go deeper than that, you'll get in trouble, okay? I have a brother with a drilling company that did exactly that. He bid a job, and it was about 100 feet deeper than the in situ test, and they drilled into a natural gas storage deal that was unmarked and unknown, and the gas company denied existence, okay, until it came to the surface, okay?
Wow.
So you got to watch that stuff, all right?
So I'll piggyback on that honesty in this industry and in this scenario is the best policy, right? So as a driller, maybe you wanted to keep some industry secret to yourself and wanted to keep it so you have an advantage. Well, but the flip side of that is when the drilling is garbage and you don't do a good job of communicating that, your bid is now 30% higher than your competitor who didn't read the drill log the same way that you did. So just be as honest as you can in these drill logs. Keep it as fair and open and honest as you can through this process. It helps everybody involved. But it is why I would continue to echo Jeff and having someone there, specifically a geothermal inspector or a geologist, someone there who can accurately record what's going on.
So real quick, I spent a couple years as director of wells for Suez North America. And when we did municipal water wells, and we look at large-scale geothermal, there's a lot of dollar amount there. And we would have a CDM Smith, a Jacobs, a Stantec, geologist logging every 5 to 10 feet, depending on the specifications, which made it, as a driller, very important how we bid it, because it can become a science experiment, but also getting to TD and having geophysical logs come in and the whole 9 yards, and having a driller's log in a journal and then a geologic or hydrogeologic log that we can marry together gets us that better information.
Just one follow-up, the value of a TC test, not only for the design of the field and the costing with the log to share with the other drillers, but don't forget to ask, how long did it take from the time you spud it in till you got the hole drilled? So a 400-foot hole that takes 3 hours to punch through like a hot knife through warm butter versus a 400-foot hole that took all week to drill to get to total depth. That's important information to know when you're going out to bid.
Over here is a question, but just a quick comment on this. So is it just me, or does it sound like the guys, the folks that are operating in different parts of the country are getting a little bit different information than what some of us are seeing in New York State? I find that interesting. New York State, as we've seen, you know, Jeff did the quick numbers, which I've run through NYSERDA and the 10,000 drilling rigs. I mean, the potential in New York State for geothermal is massive. I think we're all seeing that. There's over 700 people at this conference this year. We're going to have to find a new location to house more people. Everything that we can do to help each other grow, to buy the new rig, to train the new person, to share the knowledge. The pie is so huge, we just got to get better at slicing it up and sharing it.
Yeah, so I guess on that point, my name is Josh. I'm with the United States Geologic Survey. So I guess we've kind of been seeing from our end too that this is a growing field, and my question would be, you know, from our end we provide science products that can help inform drilling and do that on a larger scale especially. So I guess from you guys, you know, you're the people that are on the ground and this is important too, so what would be those products that would be the most important things that would help you save time, money, safety? Yeah, so hearing about what those would be really beneficial for us.
So a central repository for all of the drill logs across the country that's uniform would be super cool. I will say that right now, as we travel, sometimes it's state run and they have a database that you can search through. Maybe it's not the state, maybe it's the county. I realize this is a much bigger can of worms to open because drilling regulations vary dramatically, and I wish that was an understatement, but it's not. So if we could have a central place where we could find these drill logs, we could find information about the formation that we're drilling through that's more consistent, that would be amazing.
I would add to that, like our state Division of Water Resources, I wish they'd make their website user-friendly to find the logs. Gosh, what a mess.
Well, perhaps we as an industry then need to go to each state and bring that to their attention and start gathering their information together in a place where all of us could find it quickly. That would be a help, okay? In Oklahoma, we've got really good information on water well logs, geothermal bores. It's not very good, okay?
I got a question for the panel, and I think I have an idea of the answer, but I'd like from you guys for your opinion. How do you determine your test bore location, parameters, i.e. pipe size, that sort of thing? If you guys could kind of put some thought out to that.
Well, the first thing we start out with is the thermal load profile. Next thing we do is look at the site, what's available, and then we'll do a high-level ground heat exchanger sizing, see what'll fit, and in that process too, we're also pulling the formation logs and understanding what does the formation look like. Because we all know if we can drill deeper, we don't have to move the rig as much, cut down on the horizontal piping to a limit. So let's just say most rigs are set up for 600 feet. If we're in an area that the drillers are used to 600 feet, then we would try to maximize at 600 feet for that site. Some parts of the country, like Wisconsin, the drillers are typically set up for 400 feet, and they will growl at you if you go over 400 feet. So you got to understand the, what is the depth in certain areas. New Jersey, Massachusetts, out here we're doing more 850s. So that's what's really driving that depth. Understand the formation, the thermal profiles, and then we look at the U-bend size. Typically nowadays we've been using mostly 1.5" U-bends. So that it just all varies. It depends on the site and the drilling capabilities.
I'm trying to motivate more questions here from the audience.
So I'd like to add to that, and I want to stress the importance. When we're doing these thermal conductivity tests, we need to have contact with the engineering firm. So not only are we looking for conductivity, diffusivity, ground temperature, and drilling conditions, but let's say that we're drilling and we get to 200 feet and we hit a massive pocket of gas, right? No, that's, we talk about mitigating risk. Gas is a huge risk, right? We need to be able to have a constant line of communication with the design firm so that if challenges arise where we cannot get to the depth that they're looking for, we can have an open dialogue about what would be acceptable or another method that we could use on site, or maybe we have to go to a specialty drilling type. But I encourage you to make sure that when you're specifying these TC tests that you have someone who's available for the driller to communicate with when they run into a challenge.
I got a question. How many of you guys have done a job commercially where there was no thermal conductivity test done? I would lower my hands if I were you. Okay. If you know the area, you probably are good. And if you're drilling in the areas you understand and know, you're going to be okay. But I've got an example that happened in Oklahoma at 2 schools. One contractor went in and they had a design from the engineer. He drilled it as per the design, but there was natural gas, all right? And half the borehole was dry. And so that grout dried out, the natural gas came up, and you could actually physically measure it in the classrooms. Okay? Serious stuff, guys. So this is important when these people are telling you, know how you're going to grout these things, know how you're going to complete them, and know what other things and factors you run into, like salt, which will affect your bentonite, or natural gas, which is a real safety hazard.
Well, we've seen more and more of, you know, obviously you do stuff in dense urban, new construction, and people want to, there's only so much area on a site to put a borehole, and now they want to put it in the footprint of the building. And if you're not reporting gas as part of the test bore, what happens? Who falls responsible for that? I don't know. I don't actually drill.
Drillers, do you have a 4 or 5 gas meter on the rig?
We have gas meters.
We have gas meters, yeah.
We do have some.
Yeah.
All drillers?
Nope. Nope.
No, and it's a simple thing. It's a simple thing. It's also something simple to be put, actually, in the whole grand scheme of things, anybody in here that's putting a proposal out and you have a multi-million-dollar project to spend $2,000, $3,000, $4,000, $5,000 on someone to sit the hole and have gas monitoring equipment on site, in the grand scheme of things, that's nothing, and all it will do is save you money in the end. And, yeah, potentially save some lives. Yeah.
You know, Brock, that's a great idea, and I'm going to put that in my testing requirements. Thank you.
Who's got the mic? Oh, sorry.
So my name is Rami. I'm working for ME Engineering. So majority of the commercial projects that we work, the first thing when the client requests that we have a geothermal system, we need to have a test well. We need to do that because we need to know the formation, we need to know the conductivity, we need to know all this basic information so we can carry the design. And majority of the time the answer, no, we cannot do it now because we don't have the logistic, we need to bid it. There is too many things and we get a lot of pushback. And we ending up like, okay, we'll get some information from New York, about the geology of the location, from some legitimate sites, websites, and put some assumption. and we clarify and will be clear with the owner that this is all based on assumption. Everything could be changed when we get the test well. And we go, sometimes we bid the project, and we try to get the driller and do the test well. And then we look at the result from the test well, from the report and log, and starting revise the design again. I saw that's happening in a lot of projects. Few clients, they agree to do the test well at the beginning of the project before the design start, but a lot of them, they try to push it to be part of the contract. We tell them how risky is it, but we cannot force them more. Just my 2 cents here.
So that's the selling point that Ryan was trying to say in the previous segment, is that we have a selling problem in some regards in that regard. Yeah, that sounded dumb. So when we are putting something in front of a client and he or she wants geothermal, here's the things that you can run into, but here are all the benefits that you're working towards. It can happen anywhere. You can do this almost anywhere. There are places where, we legitimately say we're not going to drill. There's no doubt. And some of those you can find out right up in the first phone call by just calling a local, geothermal drilling contractor. You can get a no pretty quick in some places. But that selling point, that selling problem that we have by saying, here's your rebates, here are your cost incentives, all of the things that go, but to get there, you have to make sure you do it right up front. And so it might be just a different mindset. I don't know if Kevin could add to that a little bit.
Yeah, before we go there, Kevin, one of the things you have to think about is when we go through this process, Jeff, you're a mechanical engineer, right? I'm an industrial. We fix your stuff. That's the old standing joke in the engineering communities. But there is something to that, in that if we're going out there and we're going to do this process and you don't have a certified geo-exchange designer involved, they're not going to know the horizons that we're asking for and looking at. And the CGD course from IGSBA does a really good job of explaining that. I just want to put that out, okay?
So I would add, no structural engineer is going to build a building without soil tests, right? They're not going to build the structural integrity of that building and guarantee it without you going out and doing soil samples to make sure that the structure can be supported, right? No different than the geosystem. Why are we going to, the time that you're going to spend to design that system without that information, it will save them more if they just run the test in the first place and then continue to encourage them to put the test bore in the location that we can use it so that it's part of the loop field. But I would just, we keep talking about geothermal like we live in a vacuum. Well, there are other technologies, other things that get done on a project that have a lot of the same processes that we do. So I would challenge that and say, the structural guys aren't willing to guarantee that without their soil borings. Why would you? So I think it's a bit of a sales pitch, and encouraging our customers, encouraging these clients that this is ultimately in your best interest. And here are the millions of reasons why. But I would just challenge that based on what other industries do.
I think we have another question here.
I just want to add to that. Ooh, I got a great idea. So a lot of times, us consulting engineers, we help the owners or the clients put together their RFP. And if we help them, not make them, but if we help them with the thought of putting the test bore in the RFP, that it has to be done during the design phase, then it'll start to happen in our industry, and then we can have more success.
We got another one over here, I believe. Ooh, thank you.
From an owner's point of view, was he next?
Let's see. Well, he defers to
So-
you, sir.
Well, I thank my friend from South Carolina for one overall question. Is this point of view of drillers or point of view of owners of the property? If it's both, then I'm going to ask questions from as owners of properties. Jeff would know.
Ask both.
Okay. So can I just do a rapid fire series of questions? You're developing a project, okay? So you have a campus setting. You first have to identify the real estate, and you can answer yes or no. All right, this will go very quickly. It'll take about 8 minutes. You identify the real estate, timing, on campus where you can possibly drill, knowing your master plan development for the campus. I got a yes from Jeff, because he's done this already for us. So, okay, you got a yes, okay. So,
And you may have several choices, so you pick the best one that geologically might be.
well, you pick as many as you can, because
Sure.
there's going to be competition for us to put a science building and all these other things. So, I'm not getting into under a foundation, because that's kind of new for us here, but let's just say open field, like athletics field, parking lots. We have parade fields. Those are potential locations. Correct. Okay? Now you want to know the geological strata underneath it. You could use online data, like, for instance, the Geological Survey that's back here did a very wonderful survey of the geostrata, whatever you call it, the geotechnical qualities in New York for the purpose of drilling geothermal. So that will give you initial capacity in that field. Is that correct?
Yes.
Okay. Now the next step is where it gets confusing. I've done borings for structural, I've done borings for percolation tests, I've done borings for contaminated sites, you know, and there are standards. You mentioned the Unified Soil Classification Standard. You have ASHTO and some of these other ones, depending upon what you're doing. So what is the standard for geothermal? And the other question sub to that is, I've never drilled without a geologist, so I'm not sure why that's a topic. But so focusing just on the standards, what is the standard? What's the reference? Is there an ANSI? Is there an NIST? What's out there? Remember, engineers have licenses. They normally like a standard. They don't like to wing things.
Well, in our
Since their
industry,
insurance carrier won't cover them.
in our industry, we have the CSA, IGSPA, ANSI standards.
CSA stands for what?
Canadian Standards Association. Okay. It's binational standards. And
Has that been incorporated like international building code into the local building codes?
It's gone in the IMC. Yeah.
Oh, it is?
Yeah.
Okay.
And you'll see that when the geothermal section's fully developed. We're working on that. We're working on the ambient temperature loop also for that group. And so it's going to get really robust.
So it's going to go up into the IBC?
Yep.
Okay, all right. Because most,
But I can't tell you when, because those processes take time.
but you could say to your geological firm,
Yeah,
or your
well-
geotechnical firm, go ahead and use these standards.
Okay, ASHRA and IGSPA also has a testing standard that we can use.
ASHRA?
ASHRA. Mm-hmm.
ASHRAE?
ASHRAE, yeah.
ASHRA, okay.
American Society of Heating and Refrigeration.
No, I
Okay,
know.
okay.
Yes, I
So we have those out there. All
You
right?
do.
And those, unfortunately, are just the beginning. Some of the data there and some of the methods are old, but they're being updated, okay?
Okay.
Terry's chairing one of the committees that does that. And so as we wrote, in ASHRA, as we work through this, you're going to see quite a bit of change coming. It's not going to be more laborious or anything, but back to your point about having a geologist, I'm all on that.
Yeah, no, I that's why I was confused. I never done a bore without a geologist. Cool. So now it comes time you hire the geotechnical firm. Who should select the driller? The geotechnical firm?
Hang on a minute, Vinny.
Sorry.
So we
Sorry,
don't
Jeff.
use a geotechnical company to drill our test holes. We're using a licensed water well company that actually specializes in geothermal drilling, because we're doing more production drilling. A water well company comes in, specializes in maybe putting in one well for that site. We want a company that has experience doing, ground heat exchangers, because that's a whole different ballgame of drilling. It's all about production. And it's not geotechnical work at all.
So let me,
For your TC test, most geotechnical firms don't have a data logger. And then they have to, there's a
Yep.
tax rate standard
Right.
for allowing.
This comes up a lot, Terry, about people they talk about their geotechnical. Can you use our geotechnical report, for our site, So that's totally different from
you
what
say
we're
the
doing.
geotechnical report, because I know the geotech, like in New York City, a geotechnical report for structural expires in 5 years, so you have to go back and do another one. So you're saying that a geotechnical firm should not, like Muser Rutledge, should not hire, no. So then who do you hire?
Well, we typically assemble an RFP, and then we would go out and get some pricing from different qualified drilling companies.
You assemble an RFP for engineering firms.
No, we're the engineering firm. We assemble an RFP that would go out to multiple drilling companies and get pricing from multiple drilling companies that would then come in and do the drilling, set the U-bend, do the conductivity test, the installation of that test.
So you go out to drilling companies that just don't do drilling for where testing is the end point. It's drilling companies that actually do drilling for effect. They do drilling for geothermal systems. That's correct.
They do. And they'll log it to their ability and knowledge base and experience and where they drill. And what we're saying is add that additional piece of a third-party logging and have a geologist log the hole so that you get that independent view of what's happening, timing that is separate from what goes on currently.
Right. So let me ask, so Geo Exchange licensed engineer, is that what you are? How do you describe yourself? You're not the geotechnical firm, but
I'm
you stand?
a mechanical engineer.
No, I know that, but I mean.
But I went and got the certification for.
Geo Exchange certified
Yeah.
engineer?
Yes.
You put together an RFP?
Yes.
Okay. In that RFP, you're saying the driller hires the geologist, or you
No.
hire the geologist
No,
separately?
we have geologists on staff.
You have geologists on staff? Okay.
That's correct.
All right. So then your geologist has to coordinate with the driller's schedule to be on campus or on
Yes.
site to, right. And then the boring logs are owned by who? The driller or by you?
We both do them and then we compare. But the owner, you own them, but
Oh, you each do your own?
yes, we want the drilling company. They have to do that anyway to turn in. A lot of states make you actually, turn that into the state.
One geologist.
But
You got one geologist.
Our geologist though is not.
Oh, the driller's going to write his own report without the geologist. You're going to write it
Exactly.
with the geologist.
Right. Yeah. You're right, Vinny. Vinny, you have it right. So the driller is going to do his own logging, and that's really mandatory because of their license. But then our geologist that's on site witnessing the whole process is also doing the logging.
So what forms the basis of the geothermal contract?
So what goes in our specifications at the end of the day is one set of formation log, right? So at the end of the day, we're going to have to agree on the formation log between the drilling company and us.
Who's we?
Our geologist.
Okay.
And the drilling company are going to, if there's something that's different in that log, we're going to have to discuss it.
So ultimately, the Geo Exchange certified engineer determines what's in the final log for bidding purposes.
Yes, for bidding purposes, yeah.
Okay.
Yeah, because we log a lot of different things, like the penetration rate per rod, and we log everything.
We did have one question in the back, I thought. Okay, we got one here. Okay.
Yeah, just one question from my side. Dmitry Kurovsky, Celsius Energy. Maybe a bit off topic, but it's still geology matters. And we've been talking about gas, H2S, hydrocarbons, and we make it sound like a fun, but in reality it's not fun at all. And I just moved from oil and gas to this industry. And in oil and gas we have super strict regulations in terms of these matters, correct? Right now, I don't really see similar regulations in the geothermal world. And you, as a drilling company representatives and basically who work with drilling companies, maybe you can guide me on this topic and basically do have some kind of emergency response plans or basically preventive measurements. Because the moment you hit one of these bad topics, the whole name of geothermal can go sideways, correct? If it's really bad, like in case of H2S, for example.
So I'll just tell you from a regulation standpoint, it is 100% dependent on the jurisdiction. So here in the US, none of those regulations are universal from state to even county to municipality. So the response and how you have to abandon or deal with that gas pocket is specific to that jurisdiction. Now, there are regulations and there are codes or there are guidelines in each of those jurisdictions, but wherever you're drilling, you need to have an understanding of what that authority having jurisdiction is going to require of you. So unfortunately, it's not a great answer because it's so unregulated, but I would say wherever you're drilling, again, so as an example, we drill all over, right? So every time we go somewhere, we're making a phone call. We're calling the state, we're calling the county, we're calling the city to make sure that we understand what we're going to be required to do. And we keep a database of that for ourselves. But you really need to make sure that you're including every authority having jurisdiction over wherever that is. There are areas in like Michigan, where we have to have monitors and even have an emergency response team available right now if something were to happen. So it really is, the severity of the response is really dependent on where you are and the levels of gas that you're going to encounter, but the abandonment, the handling, and everything else is so dependent on that authority having jurisdiction.
So to piggyback on that, is there a certain depth that you have to have all those requirements, or every hole that's drilled, it's geo?
Every hole is drilled.
Water well, geo, doesn't matter, you have to have monitoring?
Yeah.
Okay. So in New York State, really, things don't kick in very seriously until you get it below 500 feet. And so when you hit that 500-foot mark, now you're already going to the DEC for a permit. That's why 500 is the magic number in New York State.
That's why we have a topic.
And therefore, the next topic is going to come into this and all the things that could happen after 500 feet in this state. And it's going to be a worthwhile conversation. It's actually a very, very important conversation. So your idea of having monitoring also built into your proposals, I think, is another good idea. It's a safety factor. It helps everybody. It helps the owner. It helps, the drillers, because a lot of drillers just take it for granted, and they see gas all the time. They see hydrogen sulfide. They see methane. And it's not a bad practice to have monitoring to know that you have it. We burn a rig down. It happened. A few years ago, we lost one. And we don't even know how to ignite it. We got guesses, but we really don't know. There was one lost a year and a half ago in the southern tier in a very shallow hole. And other people have lost them also in the southern tier. So it's not an uncommon thing. And to be aware of gas and the gases around you, ask Kevin. We tried to have Geo at his own home. That's another story for another day.
Garen brought up the CSA standards. CSA standards is a regulation. It's been around since 1992. In the last 5-6 years, we're working with ICSPA to basically make it a regulation here in North America as well, binational. Now, in CSA, also, if you follow CSA standard, which I'm sure they're going to do soon, on a big campus and a big project, you may have to have more than one test hole. You may have to 2 or 3 test holes, sometimes even 4 or 5. And Garen, you may want to explain under the grout side of things as to where is it necessary to have good grout and where it's not necessary to have, like cheap grout. So this way you can get an idea.
Grouting is extremely important because that's what protects the environmental aspects of what we're doing. All right. There are things in the formations that can affect the hydration of your grouts. All right. Some grouts at normal outside temperatures hydrate within, 3 to 4 hours. All right. To build their full yield strength. Some take up to 72 hours to fully hydrate. All right, so you got to know those things. And until it no longer is moving in the borehole, all right, or running out into the porosity that is in the stuff, then you got to be careful because you can run that stuff down. You can let a plug of it go out below you, and now all of a sudden we got something up above us that's going to let what we had in there. So salts are some of the things you're looking at. The mixed water pH is really important, all right, on that grouting. There's just a number of factors that our industry has that maybe we haven't done a good enough job on getting that out to the industry, all right? Yeah, okay. So I'll leave that up to Brock. Okay.
I've got two quick comments, and maybe that'll trigger some
Quick comments. We have less than a minute left before we move on to the angle drilling topic.
Real quick. See if we can catch another question. One of the things I found about a good pre-design, not just to pick your TC test parameters, but it allows everyone else on the team, like civil and structure, to tell you where you can't go with your groundlet, because you don't want to be design this thing, find out, say, no, you can't go there. We'll put another building there later. The other thing is cost. The late, great Kirk Mesher taught me a long time ago, don't beat up on the drillers. Beat up on the controls guys, because they're the ones that usually are way overpriced. You usually have fewer control points for a ground source heat pump system, but yet they're sticking it to you, but no one ever questions the controls guys. It's my personal mission now to beat up on controls contractors, so. Next question.
Thank you. Nope.
Last question.
It is not we are done. 2 o'clock. Thank you, panelists.